In this video, we're going to look at solving quadratic equations using quadratic formula. There's another video showing derivation of quadratic formula. Not every quadratic equation can be solved by factoring or by taking square root or using square root property. But we can use quadratic formula to solve any and every quadratic equation. Quadratic formula can be used. First, we must have to write our equation in standard form. Ax squared plus bx plus c equal to 0. And a cannot equal 0. If a is 0, we don't have a quadratic function anymore. And then roots of such equation can be found by using quadratic formula. The roots will be in the form of x equals negative b plus minus square root of b squared minus 4ac divided by 2a. If you remember the story of quadratic formula, negative boy could not decide whether to go to a radical party. The boy was squared because he missed 4 awesome chicks and the party was over at 2 a.m. So if you remember the story, it's easier to remember the quadratic formula. Now before we plug a, b, and c into quadratic formula, we must have a 0 on the right hand side and we must have written the quadratic equation in standard form. Means x squared terms and then x term and then constant term. And when we compare, a here will be 2, b will be 5, c will be negative 8. Right, let's see some examples of using quadratic formula to solve quadratic equations. First example, solve 2x squared plus 5x minus 8 equal to 0. So first of all, a is 2, b is 5, c is negative 8, and quadratic formula is x equals negative b plus minus square root of b squared minus 4ac divided by 2a. Let's go ahead and plug a, b, and c in here. Negative b plus minus square root of b squared minus 4ac divided by 2 times a. Turns out to be negative 5 plus minus square root of 25. Now, negative times a negative will actually become a positive. So 4 times 2 is 8. 8 times 8 is 64 divided by 4. Negative 5 plus minus square root of 25 plus 64 is 89 divided by 4. If I could break the square root of 89 into pieces, I would do that. But there's no perfect square that I can pull out from square root of 89. So we'll leave it at that point. And our two solutions are negative 5 plus root 89 over 4 and negative 5 minus root 89 over 4. See another example. Here we don't have the equation written in the standard form because we don't have 0 on the right hand side. So first step is to write the equation in the standard form by bringing 10x to the left hand side. When we bring 10x to the left hand side, it becomes positive. Now my a is 13, b is 10, c is 1. Quadratic formula says negative b plus minus square root of b squared minus 4ac divided by 2a. So this turns out to be negative 10 plus minus square root of 100 minus 13 times 4 is 52 divided by 13 times 2 is 26. Negative 10 plus minus square root of 48 over 26. Now we can simplify square root of 48 because we can write it as 16 times 4 and we can pull, this is 16 times 4, square root of 16 is 4, so we can pull a 4 out. So it turns out to be negative 10 plus minus 4 root 4 divided by 26. Go ahead and factor out a 2 from the numerator. Negative 5 plus minus 2 root, it's actually going to be 16 times 3, not 16 times 4, and that would be a 3 inside. 16 times 3 is 48. And then we have 26 in the numerator. We can go ahead and cancel between 26 and 2, and it turns out to be 13. So our final answer is x equals negative 5 plus minus 2 root 3 divided by 13. So there's our two solutions, one with the positive sign, one with the negative sign. Right. Next example, negative 3x squared plus 2x equals 21. Again, not in the standard form. So first step is I'm going to bring everything to left hand side and 0 on the right hand side. Now at this point, we can say A is negative 3, B is 2, and C is negative 21. But if we want to make our life a bit easier, we can go ahead and divide everything with the negative 1 on both sides. That way, I don't have to deal with so many negative coefficients. So it'll leave me with 3x squared minus 2x plus 21 equal to 0. So now we can say A is positive 3, B is negative 2, and C is positive 21. Doesn't really make any difference. We could work with the negative A and C, or we can work with negative B. Does not make any difference. So now use the quadratic formula because equation is in the standard form. Negative B, which is negative, already negative, B is negative, plus minus square root of B squared minus 4 times A times C divided by 2A. So it turns out to be x equals 2 plus minus square root of 4 minus 4 times 3 is 12. 12 times 21, that would be 252 divided by 6. Let's go ahead and simplify and clean it up a little. So this leaves me with 2 plus minus square root of 4 minus 252 is negative 248. And we can pull out an I. And we can also break 258 into 62 times 4 is 248. So 62 times 4 is 248. We can pull out a square root of 2 from here. So this is going to turn out to be, all right, so that's going to be x equals 2, positive 2, plus minus, we can pull out a 2i square root of 62 divided by 6. And now we can go ahead and factor a 2 out from the numerator and cancel with the 3 in the denominator. And we would be left with x equals 1 plus minus I root 62 divided by 3. And that's going to be our solution for this quadratic equation. We have two imaginary solutions in this case. Next, we're going to talk about discriminant. Discriminant tells us about the nature of the roots. Discriminant is b squared minus 4ac. What we have inside the square root in the quadratic formula, that's the discriminant, b squared minus 4ac. And that helps us determine the nature of roots. Sometimes it's not necessary to solve the equation. If you can quickly see if you're going to have real solutions or not, you may not need to proceed and actually solve it. So to find the nature of roots, nature of solutions, or how many x-intercepts you have, the same roots, zeros, solutions, x-intercepts are all the same things. So we can quickly find discriminant to figure those out. If discriminant d is equal to 0, b squared minus 4ac, if it's equal to 0, we have one real solution and it's going to be repeated. Because the degree is 2, quadratic equation, we must have two solutions. They don't have to be two distinct solutions. It could be one solution repeated. If degree d is less than 0, we have no real solution. If degree d is greater than 0, then we have two distinct real solutions. Right. For first example, find the nature of roots of the given equation. So first step is we want to write it in the standard form. 4x squared minus 8x plus 10 equal to 0. All right. So let's go ahead and find discriminant. Discriminant d is b squared minus 4ac, where a is 4, b is negative 8, c is 10. So that would be d equals b squared negative 8 squared minus 4 times a is 4 and c is 10. So it turns out to be 64 minus 160. 64 minus 160 will turn out to be negative 96. So we can see there's two imaginary solutions in this case. We have two imaginary solutions. No real solution also means there's two imaginary solutions. And that also means there's going to be no x-intercepts. Okay, next we are looking for nature of roots. I'm going to make this a negative here. So A is 3, B is negative 2, C is negative 4. Discriminant D is B squared minus 4AC, negative 2 squared minus 4 times 3 times negative 4. Turns out to be 4. Negative and negative will multiply to give me a positive. 4 times 3 is 12. 12 times 4 is 48. 48 plus 4 is 52. So my discriminant is a positive number. Again, it doesn't matter what number we get. All it matters is the sign. If it's a positive number, if it's a positive answer to the discriminant, then we will have two distinct real roots. Two distinct real roots. And we can find them using quadratic formula. We can find those roots using quadratic formula. Let's quickly go ahead and do that. For the second example, we were not supposed to find the solutions here. We were just going to find nature of roots, but we can find the solutions if we wanted to verify that we do get two distinct real roots. So the quadratic formula will give me negative b plus minus square root of b squared minus 4 times a times c. The a is 3 and c is negative 4 divided by 2 times a, 2 times 3. So 2 plus minus, this is the piece that we just found. That's what our discriminant is. And that's square root of 52. 2 plus minus square root of 52 divided by 6. And 13 times 4 is 52. Yep, 13 times 4 is 52. So this can be written as 2 plus minus 2 root 13 over 6. And we can go ahead and cancel the common factor between numerator and denominator. And it would be 1 plus minus root 13 divided by 3. So there's my two real solutions. 1 plus root 13 over 3 and 1 minus root 13 over 3. When you're looking for finding the nature of roots, you don't need to actually solve them. All you need to say is what kind of solutions you're going to get. Are you going to have repeated solutions? Are you going to have no real solutions, imaginary solutions? Or are you going to have two distinct real solutions? That was all for solving quadratic equations using quadratic formula.